Today we are working on graphing absolute value equations. Absolute value equations take the form y equals a multiplied by the absolute value of x minus h plus k. The point h, k, is the center of the graph and it's called the vertex. So let's say we have y equals the absolute value of x minus 5 plus 6. Okay. We're always going to take the opposite value of what we see inside to find our vertex. So here, the vertex is 5 comma 6. Why do we take the opposite? Because you see how it's minus h here. So whatever's inside, we have to take the opposite value to find our vertex. Negative 5, the opposite value would be 5. On the outside, we can just take what we see. So the vertex for x minus 5, absolute value of x minus 5 plus 6 would be 5 comma 6. The graph is shaped like a V. It is symmetrical on either side of the vertex, which is nice. So let's take a look at our first example down here. Here we have y equals the absolute value of x plus 2. We don't have a k value, so we know that's 0. And inside is plus 2. So we know that our vertex is going to be negative 2, 0. And I can clearly find that right there, negative 2, 0. From there, if we move our value of x to the left, we see it here at negative 3 comma 1 right there. And on the other side, if we move 1 to the right on our x value, that'd be negative 1 comma 1. Do you see how both y values are the same? That's because it's a V shape and they're going to match each other as they go. And we're going to be able to use that as we go along. A lot of busy stuff happening on the screen. All right, next example here, y equals the absolute value of x minus 2 minus 2. So my h value and my k value, we're going to take the opposite of what we see inside, so it should be 2, negative 2 as an ordered pair. Go to the right 2 down to negative 2. That's my vertex. That's going to be the bottom. I know that it's going to be a positive looking V, like the arrows are going to be up because it is positive on the outside here. And we've got 2, negative 2. If we go to the right 1, we get here at 3, negative 1. And if we go to the left one, it'd be 1, negative 1. Once again, our y values match up perfectly, even when our x values change, and they are symmetrical. Here on the right, we've got a negative symbol on the outside. That's just an automatic signal that the V is going to be turned upside down. The symmetrical V is upside down. That's a huge clue for you if you see that. Negative on the outside means the whole thing is going to be upside down, going the opposite direction. Our h and k, we can still find our vertex, x minus 4, so I know it's going to be 4, and our k value is 4. Make that an ordered pair, 4, 4, boom. And once again, it's still symmetrical, even if it's facing the opposite way. If I go 1 to the right, that'd be 5, 3, right here. And if I go to the left one, 3 is also at 3. Symmetrical. All right, let's look at some examples and work through how we're going to do that. First, we're going to learn how to graph an absolute value. So the first thing we want to do is plot the vertex. That's that hk value. That's going to be really important. And then we're going to choose two x values on either side of the vertex, each equal distance from the vertex. So if we move to the left 1, we move to the right 1. If we move to the left 8, we move to the right 8. Plug the x values into the equation to get the y values and plot your remaining points. So if I had y equals the absolute value of x plus 2. Then I know my h and k, my vertex, the first thing I'm going to find. This here would be 2 and 0. Then I would like to make a little x and y value chart. We'll start in the middle. If we go 2 here, we know that y is 0. So let's move backwards here, 1, 0, and 3, and 4. We'd be able to solve from there. And we're going to do that with some examples in a moment. All right, let's graph the y equals the absolute value of x minus 3 plus 2. And we're always going to start with our vertex. Our vertex here is going to be 3, comma 2. Remember, we take the opposite value of what's inside. This says negative 3, but we take the opposite value for absolute value. 3, 2. So I have my first point plotted. And over here in my box, I'm going to go ahead and fill that in. Let's take values to the left, equal distance. Let's just go 2 and 1, 4 and 5. We know it's going to be symmetrical. So we know that 2 and 4 should match and 1 and 5 should match. So we don't have to do the work 4 additional times, just 2. So let's go ahead and plug in our value. Let's start with number 2. Y equals the absolute value of 2 minus 3 plus 2. The absolute value of 2 minus 3 is negative 1. The absolute value of negative 1 is 1. 1 plus 2 is 3. Should get 3 here, and we should get 3 here as well. So let's go ahead and plot those. 2 comma 3, 4 comma 3. Okay, this is looking great so far. All right, let's plug in our next value. Y equals the absolute value of 1 minus 3 plus 2. 1 minus 3 should be negative 2. The absolute value of negative 2 would be 2. 2 plus 2 is 4. So we should get a 4 there and a 4 there. 1, 4, and 5, 4. From there, that's plenty of information. It's symmetrical. It's looking good. You're just going to make your best attempt at a straight line, or my best attempt at a straight line. The graph y equals the absolute value of x minus 3 plus 2 should look like this. Okay. Here we have y equals 2 times the absolute value of x minus 3. It's positive, so we know it's going to go in a positive v shape. What would our h and k be? There's nothing in here, so I think we have to assume it's 0. X isn't being added or subtracted by anything. And negative 3 on the outside. So let's graph that. 0, negative 3, that's down here. And let's go to our table, put it in the middle, 0, negative 3. So we'll do negative 1, negative 2, positive 1, positive 2. All right, let's start filling in our x values. Remember that we don't have to do anything 4 times, we only have to do it twice. So here we got y equals 2. Let's take this one to start. The absolute value of negative 1 minus 3. What's the absolute value of negative 1? That's just 1. And 2 times 1 is 2, minus 3 is negative 1. So if we have negative 1 here and negative 1 here, let's see if that works out on the graph. Negative 1, and 1, negative 1. All right, I'm seeing a V shape. This is a good start. Next spot, let's just do positive 2. Y equals 2 times the absolute value of 2 minus 3. Absolute value of 2 is 2. 2 times 2 is 4. Minus 3 is 1. So it should work out to be 1 for both of these. 2, 1 here, and negative 2, 1 here. This looks like a pretty good symmetrical V shape to me. They're lining up, the y values match, the x values are equidistant apart. Perfect. So we have now graphed a couple absolute value equations. Let's do one more example. Negative, we got a negative here. So what do we know right away? It signals to us that the graph is going to be upside down. It's not going to be like a positive looking V. It's going to go the other way. That's a signal to us. The vertex remains the same. Inside we have positive 2, so it's going to be negative 2 here, negative 1. That's going to be our first point. Once we've found that, we can do anything in the world. Negative 2, negative 1 here, and we think it's going to be upside down. Let's go first, move 1 to the left for negative 3, negative 4, negative 1 here, and 0. And again, these should match, and these should match if they are equal distance apart, which they are. So let's solve for negative 3, y equals, whoa, negative absolute value of negative 3 plus 2 minus 1. The absolute value of negative 3 plus 2, we can simplify that absolute value of negative 1, which would be positive 1. Now, don't forget, we have this negative symbol. We have to bring that back down. Enters the fray at this point once we've simplified as much as we can. Negative 1 minus 1 is negative 2. Should match there. Negative 3, negative 2, negative 1, negative 2. Not sure why it's doing that. Don't love it. All right, let's do one more on the outside there. Last example, y equals negative. Let's do the absolute value of 0 plus 2 minus 1. 0 plus 2 is 2. Absolute value of 2 is 2. Then we got to bring both these down. Negative 2 minus 1 would be negative 3. Should match here. Negative 4, negative 3, and 0, negative 3. And that looks like a pretty good symmetrical graph. All right, those are 3 examples of absolute value equations and graphing those.